The Lake Michigan Triangle is shaped like a dagger. This section of Lake Michigan has, over the centuries, earned a reputation for a place where all kinds of weird things and disasters have taken place.
Lake Michigan's water just turned the clearest it's been in a century, and that clarity is a warning sign, not good news. What if the cleanest looking water you've ever seen meant the lake underneath it was dying? Because right now, you could wade into Lake Michigan, look straight down, and count your own toes through 10 feet of water, and almost nobody understands why that's terrifying. That clarity didn't come from cleanup crews or pollution laws. It didn't come from decades of environmental policy finally paying off. It came from a tiny striped shell that wasn't supposed to be here at all, a shell that crossed an ocean by accident and quietly rewired one of the largest freshwater systems on the planet. In 1988, a biologist sorting through a routine water sample in Lake St. Clair, just east of Detroit, found something that didn't belong. A shell no bigger than a fingernail. Striped, unfamiliar, a zebra mussel native to the Caspian and Black Seas thousands of miles away. It had crossed an entire ocean inside the ballast tank of a European freighter, ridden into the heart of the continent, and slipped into the Great Lakes like a seed dropped into open ground. Nobody panicked. It was one shell, one species, in one sample, in one lake. But a single female zebra mussel can release around 1 million eggs in a year. Not 100, not 1,000. 1 million, from one female, every year. Within 3 years, the species had spread to all 5 Great Lakes, Superior, Michigan, Huron, Erie, and Ontario, without a single border, dam, or barrier slowing it down. By 1992, zebra mussels made up roughly 98% of all mussels found in Lake Michigan, carpeting rocks, pipes, intake structures, and the hulls of century-old shipwrecks in dense gray clusters. Then came round 2. A second invader from those same Eastern European waters arrived close behind the quagga mussel. One fisheries biologist described it in 4 words: zebra mussels on steroids. That description wasn't an exaggeration. Unlike the zebra mussel, which needed a hard surface to anchor onto, the quagga didn't need rocks or pipes or hulls at all. It could colonize bare sand, soft mud, the open, featureless floor of the lake bed itself, and it could feed in cold, deep water year-round, all the way down to 540 feet water, so cold and dark that the zebra mussel could never survive there. So the quagga did to the zebra mussel exactly what the zebra mussel had done to everything else in the lake. It took over. By 2005, quagga mussels made up more than 97% of the mussels collected in Lake Michigan. In some locations, researchers measured densities exceeding 7,000 mussels per square meter, with isolated clusters topping 35,000. Picture a single square meter of lake floor, an area roughly the size of a card table packed with 35,000 individual shells, all filtering, all feeding, all reproducing. Today, scientists estimate roughly 300 trillion invasive mussels live on the floor of Lake Michigan alone. Across all 5 Great Lakes combined, that number climbs towards 750 trillion. That's not a typo. That number is larger than the number of stars in the Milky Way, multiplied several times over, and it's sitting on the bottom of one lake. Here's what trillions of filter feeders actually do, mechanically, every single day. Each mussel pulls in roughly 1 liter of water and strains out the microscopic plants and animals floating inside it, the phytoplankton and zooplankton that form the bottom rung of the entire food web. Multiply that by 300 trillion animals, run it continuously for 3 decades, and the lake gets filtered over and over until almost nothing living is left suspended in the water column at all. That's why it turned clear. The clarity isn't cleanliness, it's emptiness. And the version of this story you may have already heard invasive species magically cleaning up a polluted lake leaves out exactly what that emptiness costs. And here's where this stops being a story about water clarity and becomes a story about who's been quietly paying the price the whole time. Behind the scenes of all that sparkling water, the numbers were collapsing. Between the late 1990s and the late 2000s, spring phytoplankton in Lake Michigan fell by roughly 87%. Overall phytoplankton levels in the lake have dropped by about 90% since the mussels took hold. The zooplankton that feed on those plants crashed alongside them, with nothing left to sustain the next link in the chain. The mussels hadn't cleaned the lake, they had eaten its foundation and left the rest of the ecosystem standing on nothing. Think about that for a second. The base of an entire food web gone, not damaged, not reduced by a manageable margin, gone by close to 90%. And everything built on top of it, every fish, every bird, every commercial fishery that depends on this lake is now living off the remains. Which brings us to the fish that mattered most. The lake whitefish has been the backbone of Great Lakes commercial fishing for over a century. In Michigan, it has historically made up around 90% of the commercial catch, worth roughly $5 million a year at the dock from state-regulated boats alone. This wasn't a niche species or a hobbyist's catch. It was the industry. In 2009, the Lake Michigan whitefish harvest peaked at nearly 7 million pounds. By 2024, it had collapsed to under 2 million pounds. That's a drop of about 70% in 15 years. In Lake Huron, where the decline started earlier, the harvest is down roughly 80% since 2000. And if a falling harvest were the only problem, the fishery might have survived it. Harvests fluctuate. Populations recover. But then biologists looked closer at the fish that remained and found something worse. Whitefish are still hatching, but their young are starving. The larvae depend on exactly the kind of tiny plankton the mussels have stripped from the water. With nothing to eat in their first days of life, most of them die almost immediately before they ever have a chance to grow, mature, or reproduce. So the population isn't just shrinking, it's aging. Many of the whitefish still swimming today are in their mid-20s old for the species, and like any aging population, they reproduce poorly. Biologists have watched entire local populations grow old and vanish in front of them, with almost nothing coming up behind to replace them. It's not a slow decline with a recovery curve waiting at the bottom. It's a population running out the clock. State and tribal regulators recently set the most conservative catch limits ever recorded for Central Lake Michigan, slashing the allowed harvest by about 94% in a single year down to just 10,000 pounds, from over 170,000 the season before. Of the 18 genetically distinct whitefish populations across Lakes Michigan and Huron, 14 are now considered imperiled. One tribal resource director put it plainly, the mussels have driven Great Lakes whitefish to the edge of being wiped out entirely. So scientists started asking a desperate question. In a lake with 300 trillion mussels, was there anything left in the system that could actually fight back? The answer had been swimming in the same water the entire time. And for 100 years, fishermen pulled it out of the lake and threw it back dead, out of pure contempt. Meet the freshwater drum, Aplodinotus grunniens. In the Great Lakes, most people know it by other names, sheepshead, croaker, grunt. It earns those nicknames from a strange, low-drumming sound it produces by vibrating muscles against its swim bladder, a noise you can sometimes hear right through the hull of a boat, echoing up from the dark like something the lake itself is muttering. For generations, anglers treated it as the lowest fish in the lake, a garbage fish, a trash catch, not even worth the trouble of releasing properly. There are documented accounts of fishermen hauling one in, killing it on the spot out of pure contempt, and throwing the body back into the water. Not a fillet, not bait, just discarded, like the fish had personally offended them by being on the end of the line. Nobody wanted it. But the version of the drum that anglers believed in the worthless nuisance was hiding the most important set of teeth in the entire lake. Because the freshwater drum is the only native Great Lakes fish equipped with heavy pharyngeal teeth, a powerful set of grinding plates set deep in its throat, strong enough to crush a mollusk shell outright. It evolved that exact tool over millions of years, long before any human set foot near these waters, to feed on native snails and clams. That adaptation sat dormant for generations, doing its quiet, ordinary job on a small native mollusk population. Then the invaders arrived, and everything changed. The drum looked at the carpet of zebra and quagga mussels now covering the lake bed and recognized something the rest of the ecosystem could not. Food, one Great Lakes conservationist said it better than any scientist could. The sheepshead, he argued, is probably the single most important mussel predator in the entire system, and almost nobody knows it. He wished fishermen would finally see the fish for what it is. Not garbage. A specialist, the one organism in the entire lake that arrived pre-equipped for exactly this catastrophe. The lake spent decades throwing away the only native animal that arrived pre-built to crush the very invaders now destroying it. That is the genuinely astonishing part of this story. Out of every native fish in one of the largest freshwater systems on Earth, exactly one carried the right tool for the exact catastrophe that was coming, long before the catastrophe ever arrived. Research in the Western Great Lakes confirmed it. Freshwater drum readily consumed zebra mussels, and the largest drum, the ones over roughly 15 inches long, feed on them almost exclusively. A big drum is a living mussel grinding machine, working the lake bed day after day, doing for free the job that costs water utilities and power plants over $500 million a year to do with chemicals and mechanical scrapers. For a moment, it sounds like the story resolves itself here. A native specialist, perfectly evolved, quietly working against the very disaster threatening the lake. The kind of detail that feels almost too clean to be true. It is too clean to be true. So the obvious thought is the hopeful one. Native fish, perfectly adapted, eating the invaders. Problem solved. It gets more complicated than that. When the U.S. Geological Survey actually studied how much of a dent the drum could make, they ran into a hard limit written into the fish's own body, a limit no amount of population growth or conservation effort can get around. The smallest drum capable of crushing a zebra mussel shell at all is already about 10 inches long. Below that size, the teeth simply aren't strong enough, which means every single drum spends years of its life, its entire juvenile stage, completely unable to touch a mussel. Only the largest, oldest fish ever become serious mussel predators. On top of that, researchers found drum are limited in the size of mussel they can actually handle, even as full-grown adults. They cannot eat the whole population at every life stage. A drum capable of crushing a mature mussel might still be unable to process certain size classes efficiently, leaving entire cohorts of mussels essentially safe from predation regardless of how many drum patrol the lakebed. The study's conclusion was sobering. While freshwater drum may reduce zebra mussel numbers locally, that size limitation likely means they cannot serve as a fully effective control on the invasion. One specialist fish, no matter how perfectly evolved, cannot out-eat 300 trillion mussels that each lay 1 million eggs a year. The math simply doesn't close. Even if every drum in Lake Michigan grew to maximum size and fed exclusively on mussels around the clock, the reproductive output of the invasion would still outpace the predation. The hero was real. The hero just wasn't enough. And this is the part of the story that still doesn't quite make sense, even to the people studying it, because there's a second fish in Lake Michigan that eats mussels far more effectively than the native drum ever could. It isn't native. It's the round goby, a small bottom-dwelling fish from the same Eastern European waters that produced the mussels in the first place. It arrived the same way they did, in ballast water around 1990, and it came with its own shell-crushing structure in its throat-convergent evolution shaped by the same ecosystem the mussels came from. The goby thrives on a diet of zebra and quagga mussels, and there are now billions of them spread across all 5 Great Lakes, working the bottom constantly, relentlessly, in numbers the native drum could never match. In experimental plots where scientists cleared mussels away entirely, native colonization should have bounced right back within seasons. Instead, gobies showed up almost immediately and picked off the young mussels as fast as they could settle, suppressing recolonization far more aggressively than any native predator observed in the same plots. An invasive species, accidentally functioning as one of the only effective brakes on another invasive species. The lake's most effective mussel predator is not the native fish we ignored for a century. It's another invader we never invited, and never intended to bring here either. But the goby is no clean savior. It carries a darker cost, one that ripples up through the entire food chain. When gobies eat contaminated mussels, they can pick up botulism, then pass that toxin up the chain to the fish and water birds that eat the gobies, triggering mass die-offs along the shoreline loons, mergansers, gulls, all found dead on beaches in numbers that puzzled observers for years before the chain was finally traced back to the mussels at the bottom. So the lake is left with a brutal arithmetic. The native specialist that belongs here can't eat enough. The invader that can eat enough is poisoning the birds. There is no version of this where the ecosystem simply heals itself, no quiet equilibrium waiting just out of view. Every available option comes with its own cost attached. There's a reason this story keeps getting told, and it isn't nostalgia for what the lake used to look like. It's that the stakes keep expanding the closer you look. The Great Lakes hold roughly a fifth of the world's surface freshwater. Recreational fishing across them is worth more than $7 billion a year. Millions of people in 2 countries draw drinking water, industrial cooling water, and shipping access from this same connected system. What's unraveling in Lake Michigan isn't an isolated local problem, it's a preview running in real time. And everyone watching it closely knows the clock is running out on the whitefish. The response has finally started to scale up, after decades of the threat outpacing the funding meant to address it. In late 2025, a bipartisan bill, the Save the Great Lakes Fish Act, was introduced in Congress, proposing $500 million over 10 years to coordinate a real fight against the mussels. It's the kind of sustained, large-scale commitment the crisis has needed since the first shell turned up in 1988, arriving roughly 4 decades late. On the water itself, researchers ran a pilot project in Good Harbor Bay using a molluscicide made from the dead cells of a naturally occurring bacterium, a targeted approach designed to kill mussels without poisoning the rest of the ecosystem around them. On a treated reef, mussel density dropped by about 95% in the weeks that followed. It worked. The catch is scale. Treating one reef is one thing. Treating a lake holding 300 trillion mussels across thousands of square miles is another problem, entirely a difference not of degree, but of category. And the funding to even attempt that scale has, for years, been a fraction of what other Great Lakes threats received, even as this one quietly became one of the most consequential. Everything needed to mount a real defense is finally coming into place. The legislation, the science, the public attention building behind it. The hard truth is that the whitefish may not have time to wait for it. Biologists trying to rebuild the population by hatching young fish in rivers and stocking them back into the lake are struggling to even catch enough adult whitefish to run the experiment in the first place. The very fish needed to save the species are becoming too scarce to study. With the lower lakes turning increasingly barren, the fishing that remains is shifting north, into the colder. Mostly mussel-free waters of Lake Superior, the last stronghold, the one major basin the invasion hasn't fully claimed yet. Fishermen are following the fish north, chasing the last cold water the mussels haven't reached. Which brings us back to that crystal clear water, and the swimmers standing chest deep, counting their toes. For a long time, people looked at that clarity and called it the cleanest the lake had been in a century. Tourism boards highlighted it. Visitors photographed it. They read it, understandably, as a sign of recovery proof that the lake was finally healing after decades of industrial pollution. It was the opposite. That clarity is the visible signature of a food web that's been filtered down to almost nothing. The optical proof of an emptied lake, not a healed one. The same transparency that makes for a beautiful postcard is the direct, measurable result of a 90% collapse in plankton. The one native fish that arrived, built to fight the invasion, is still down there right now, grinding mussels in the dark, doing exactly what it evolved to do, one shell at a time, against an invader that multiplies by the trillion every single year. It simply can't do it alone. And for 100 years, we threw it back. If this story changed how you'll look at clean water the next time you see it, that's exactly why this channel exists. We dig into the hidden mechanics of North American ecosystems every week, the invisible systems running underneath the events that make headlines, and the next chapter of the Great Lakes story is already being written, right now, on the lakebed beneath those clear blue waters. Subscribe, and watch the video on screen next, where another ecosystem's collapse went the opposite way.